Welcome everyone. Today's session explores a simple question: what happens when a computer sees an image? Teaching machines to see epistemic regimes of vision in the age of AI. So we'll look at how machine learning classifies visual cultural data and why this matters for art history and visual culture. This is especially critical when we rely on automated tools in research or curation, image clustering, classification, or search. We'll unpack this using a real-world dataset and tool. As a fun introduction, I'll start with the following two pictures. Do you recognize them? Is there something that stands out in these two pictures? The intention behind showing these two images is to demonstrate how seemingly minor technical artifacts, such as watermark, can serve as epistemological entry points for the interrogation of authorship, aesthetics, and algorithmic agency. So let us begin with this incident that caused both amusement and concern within the field of AI aesthetics. There was a time in the early 2020s when many AI-generated images circulated which had watermarks. However, these watermarks weren't spelled correctly, for example, Shutterstick instead of Shutterstock, and so on. That's why I also integrated these random pictures, because of the watermarks. The left image has several watermarks across the center. The right image has what appears to be a Getty image watermark in the bottom right corner. Why is this significant? Watermarks are not semantic objects. They are not content in the strict sense. Their presence is a mark of ownership, meant to be seen but never interpreted. The AI had no need to invent it. Its inclusion was not prompted by a user prompt or by aesthetic intent. Rather, it suggests that the model encountered the watermark repeatedly during training, that is, during using copyright-protected material. This constitutes more than a legal irregularity. It is a rare empirical trace of the otherwise opaque epistemologies of AI training data and corpora. It is an evident demonstration of both the improper use of training data and the fundamental operational logic of such methods. The presence of the Getty watermark in the AI-generated image reveals a crucial limitation, whereas every person who lives in the capitalist digitized society would have recognized the watermark as extraneous and thus excluded it, the model reproduced it as part of the visual pattern it had statistically associated with image realism or good images. In doing so, it inadvertently exposed the condition of its own productions. In the fact, we might say that the model, through this gesture, betrays its own medium. It renders visible what is typically meant to remain hidden. Much like in Brecht's epic theatre or Hartfield's photomontage, the illusion is not sustained, but rather disrupted. The model, unable to uphold the fiction of photographic authenticity, makes its output with a trace of its machinic origin, a break in illusion that calls attention back to the mechanisms behind the image. Such artifacts offer powerful teaching moments. They render visible, quite literally, the invisible infrastructure of data extraction and model training. In order to provide students with a tangible and reflective understanding of how machine learning models operate, particularly with regards to visual classification, I have chosen to integrate practical experimentation. For this case, I use Teachable Machine, a browser-based Google tool that allows for accessible, low-threshold interaction with supervised learning algorithms. The idea is to build and train a small-scale model collaboratively with students, including the selection of image corpora. However, for the sake of this presentation and to keep within our time constraints, I have prepared and recorded several of these experiments in advance. We will view them as short video demonstrations. For those who don't study art history, this even provides a small insight into Baroque paintings, classicism, and Rococo. So for the first experiment, we focus on Baroque painters, specifically on Artemisia Gentileschi and Michelangelo Merisi da Caravaggio. To train the model, you need to upload examples for 2 different classes. I created 2 classes. For the first class, I chose image of paintings by Artemisia Gentileschi, sourced from Wikimedia Commons under Creative Commons license. For the second class, I choose paintings by Caravaggio, likewise sourced from the same platform. When you've done that, then you let the model train with this data. And once the model is trained, we can test it either with live camera input or with static images. So we will afterwards upload an image to test the model. And because both artists depicted the same dramatic biblical scene, the beheading of Holofernes, I choose Caravaggio's version of Judith beheading Holofernes as a test image. And the test, surprisingly, the model was highly confident, 100%, that this painting belonged to the Gentileschi corpus. This result is obviously incorrect, but didactically valuable. To give the model another chance, I run a second experiment with 2 painters from clearly different historical periods. Perhaps it was a bit unfair to choose 2 similar artists from the same area. Teachable Machine probably isn't trained yet as an art history professor. So we take artists from different periods. We have a 200 years gap between Caravaggio's Baroque paintings and Jacques-Louis David's Classicistic paintings. So we add Jacques-Louis David for the first class and we keep Caravaggio for the second class. And again, I trained the model on these representative works. And for the test image, I selected the painting, the Madonna of the Rosary from 1604, and which is attributed to Caravaggio. And let's see what the model training. So you see, it's also sometimes a bit time consuming. Even these small mini experiments take some time. But we should nearly have it. If we don't switch tabs. Yes, now we don't upload, we don't show something in front of the webcam, but take this painting from Caravaggio. So the model assigning it 74% to Jacques-Louis David, despite the attribution to Caravaggio, which makes only 26% according to the model. This massive misclassification again underscores the limitations of pattern-based recognition when temporal, stylistic or cultural context is not computational. Now, at this point, we move to a more radical contrast to challenge the model's categorical reasoning. I trained the model using photographs from a demonstration from 1989 in Mexico City and Rococo paintings known for their pastel color palettes and ornamental lightness. All images again from Wikimedia Commons under Creative Commons license. And then after training, I introduced a Japanese woodcut print, an entirely different cultural and aesthetic artifact. And let's see what it says. The model is not capable of declining to categorize. It must assign any given input to one of the known classes. There is no epistemic space for unknown or other. Hence, it forcefully classifies the woodcut as 95% photography of a political demonstration and 5% of Rococo, despite the evident incongruity. This raises an important theoretical point. The model cannot know. To be unaware is not an available computational state. The absence of a null hypothese is itself a critical insight for students, especially in a world increasingly shaped by algorithmic judgment. So there is always a nearest neighbor for an AI model. Every answer is like an arrow pointing to a location in this space. It almost always points to a place where nothing actually is. In 99% of the cases, it's precisely not there. But it is always searching for something nearby and eventually chooses the closest neighbor. So, to end on a more successful note, perhaps to align with the technological optimism often expected from AI applications, I added one additional photography from the same Mexico City protest context. So this time the model was trained with the Mexico City images and the Rococo paintings and was trained the same way, but the test was much easier, and this time the model performed convincingly, assigning it correctly to the Mexico City protest photograph class, as you will see in a second. So these short experiments, while seemingly simple, open up extensive discussions. They added the technical structure, epistemological assumptions, and ontological limits of machine learning in visual domains. En passant, this mini experiment shows also the time-consuming nature of working with AI tools in practice, a reality often glossed over by the frictionless narratives of automation and efficiency. By engaging for such hands-on exercises, I aim to foster not only computational literacy, but also a deeper critical understanding of the socio-technological systems we are all likely to encounter and co-create in both academic and professional contexts. So thank you very much for your attention.